Okay. Well, this problem is going to involve a prism that looks kind of like this, and we're going to have a prism that's made of some type of a glass where the index of refraction is 1.5. Now the interesting about this prism is that it's going to be an equilateral prism. The light is going to enter this side at an angle to the normal of 45 degrees. What we'd like to know is what angle does it come back out of what angle does it come back out of the glass? So what is this angle here? Okay. Now, in order to figure this out, we're going to have to, I'm going to blow up this region here. So let's do that like so. And we've got the incoming ray here. In fact, let me try actually doing this in a different color. Now, the different color, this would be, let's try using this red here. So this comes in, and that is at 45 degrees. The question now is, what is it going to come out here? What's this one going to be? Well, in order to calculate that, we need to do a little bit of sine law. So, Ni sine theta I equals Nr sine theta R. And since we're looking for theta R here, theta R is going to be equal to inverse sine of Ni sine theta I all over Nr. And in this particular case, that's going to work out to be air is Ni, so 1.0003 times sine 45 divided by 1.5. Now if we work that out, we're going to get the first angle to be 28.1 degrees. So this is now, we know, is 28.1. Well, how can we find now the angle at which, if we continue this along here, how do we find the angle which is incident at the second interface, going out of the prism? So what we're looking for now is this angle here. Let's call this the new theta I. Well, in order to do that, a really easy way is to make use of the fact that this is an equilateral triangle and that this angle is 60. So we know that this is 60. If we know that, then we know that this angle plus this angle plus this angle has to equal 180. And we also know that this angle is complement to theta R here, and we also know that this angle is complement to theta I here. So we can actually work towards that. You can probably see the math now how that's going to work out. This angle here, let's call it phi or phi, can't remember which. And so we'd say that's going to equal 90 minus 28.1. And so that's going to give us a value of 61.9 degrees. So now we know that this is 61.9. Now, using the fact that the three angles of a triangle all add up to 180, we should be able to get this angle now. We could call this angle, for example, alpha. And we'll say, all right, well, that means alpha is going to equal 180 minus 61.9 minus 60, right? Because there's 60 and 61.9, and all three have to add up to 180. And so we're going to get an answer for alpha of 58.1. Now, once we have alpha, it's only one last step to get our new theta I going out of the prism back into the air, and that is that our new theta I is going to be the complement of 58.1, and that's going to give us 31.9. So now we know that this angle is supposed to be 31.9. Therefore, what's the angle where it comes out? What's this angle here? That's our final answer that we're looking for. So again, in that case, we have to do the same equation. Theta r is going to equal the inverse sine of, now in this case, it's exactly this equation again. Oops. It's exactly this equation again. The only difference is that in this case, Ni is 1.5. Ni is our incident material, or the one that we're leaving, is 1.5. So it's 1.5 sine 31.9 over, where are we going to? The refracted material is air again, so 1.0003. And if we plug that through, we're going to get a theta r of 52.3 degrees. And that's our final answer, and that's what this angle is right there. So when we leave the prism, we're leaving it with a refracted angle of 52.3. And that's our solution for this problem. See you next time.